All right. What about for a weak acid? Which is going to be more powerful? Which is going to be present in greater amounts? The original acid. So which side is going to be, or which top or bottom is going to be larger? The bottom is going to be larger. These are going to be smaller. The Ka value is going to be small. Ka values for weak acids frequently are in the 10 to the minus 4th to 10 to the minus 20th or 10 to the minus 30th quantity.
You should put very small.
No, because that one you actually, the number is something you actually will have to use. Okay? All right. So, this is how you come up with an acid dissociation constant, Ka. All right. Questions on this? We're just kind of defining a lot of things here. We're not really, doing anything new yet. I have to do that at the beginning. All right. Here's another thing that ought to be a reminder, I hope. There are 6 recognized strong acids. Let's see if we can come up with what they are. So I'm going to have Jada and Weber rock, paper, scissors for me. Ready? Okay, you get to go first. Give me one of the 6 strong acids.
Can I look at my notebook?
You could, but I hope you wouldn't need to.
Oh.
But you will. Go ahead.
Hydrochloric.
Ah, hydrochloric.
I should have known that.
Excellent. Okay. McKay, I guess you're next in line. Say it again? Hypobromous is not, unfortunately. Kyle, have you got one? Nitric acid is one. Good. All right. Sarah?
Let's see.
Hydrobromic?
Hydrobromic, yes.
Is this kind of what you were thinking earlier, McKay? Okay. All right. Mikkel.
Well, hydrofluoric.
Hydrofluoric is not, as it turns out. Hydrofluoric does exist.
Oh.
It's very useful because it'll etch glass, but it is not a strong acid. Alicia.
Perchloric.
Perchloric. Ooh. What's the formula for that?
HClO4.
HClO4. Excellent. Okay. Natasha. Close, but it's not hydro. Just sulfuric acid. Okay? Sulfuric acid is H2SO4. Hydrosulfuric acid would just be H2S. And that's, while it is nasty stuff, it's not considered one of the 6 strong acids. All right.
That's just called sulfuric.
This is just sulfuric acid. Because what is this ion called? SO4 minus. Sulfate. So we replace the 8 with uric. Okay? Jada? Hydroiodic. Good. HI. Excellent. Excellent. So you saw that?
What if that red marker just mysteriously disappeared one day?
Then I'd only be able to write in red and you'd have to memorize everything.
Dang. Great.
Now, just as a question, a theoretical question here, you look at the halogens, fluorine, chlorine, bromine, iodine. Hydroiodic acid, HI, hydrobromic acid, HBr, and hydrochloric acid, HCl, all dissociate completely. Hydrofluoric acid does not. Why?
Because it likes to be different.
What's that?
Electronegativity.
Because of the electronegativity difference. Good. The electronegativity difference between hydrogen and fluorine is so strong it doesn't come apart as easily. Okay? Nicely done. Okay? Now, hydrofluoric acid is kind of fun, nasty stuff. It tends to give off fluorine gas, which is exceptionally reactive. But hydrofluoric acid has to be stored in plastic bottles because it'll actually eat through glass ones. The other three halogen acids won't do that, but hydrofluoric does. Kind of weird.
Funny story in which they found that out. I'm serious, no.
I don't have one. Do you have one?
Dang, no.
Don't they clean like pools with hydrochloric acid, trying to get them to deposit off, right?
Yeah, hydrochloric acid is great for dissolving metal deposits. Most strong acids will do that. Hydrofluoric acid, though, is used industrially to etch glass. So if you want to etch a design into it, hydrofluoric acid is the way to go. Just means you have to store it in plastic. Okay? So these are the 6 strong acids. Make sure you know them. And by know I mean memorize.
For a multiple choice question?
Maybe. But we could also throw something out there that said, let's say, chlorous acid, or chloric acid, HClO3. Does it dissociate completely or not? It doesn't, because it's not one of the 6 strong. Okay. Incidentally, I should also mention sometimes phosphoric acid is included in this, but not always. Okay. Phosphoric acid, the dissociation constant is large, but maybe not very large. I don't know. Okay, so let's compare some properties of strong acids and weak acids. Take a second and construct this table for yourselves, and we will fill it in together.